the vocabulary you need to know. The first one is ordered pairs, and basically what this means is a pair of coordinates that correspond to the numerical values on the x and y plane. Secondly, we have quadrants, and these are infinite line sections on the coordinate plane. Third, we have relation, which is when one coordinate plane corresponds to another in an ordered pair. Then we have domain, which is a set of values for the independent variable. We have range, which is the difference between the lowest and the highest value. Then we have function, which is a relationship or expression involving one or more variables. Then we have vertical line test, and basically what this means is a test that I use to find out whether a graph is or isn't a function. Then we have the independent variable, which is the thing that is purposely changed. Then the dependent variable, which is the thing that changes because of the independent variable. Then we have functional notation, which is the way a function is written to make it shorter. And lastly, we have the Cartesian coordinate plane, which is a system that specifies coordinates by numerical values.
We have to talk about graphing a function, or figuring out whether or not a graph is or is not a function. So an example of this is a parabola, which looks like this. So if we want to figure out whether or not this graph is a function, there's a very easy thing that we can do. And as mentioned in the vocabulary, for the vertical line test, you gotta draw a line and see whether or not the graph hits more than one point. So since it does not hit more than one point, we can say that this is a function. Now, in order to find a domain and range, we have to go a little bit deeper. So the domain is essentially the x-axis, while the range is the y-axis. So since it's a parabola, we know that it'll expand outward until it hits every single x-coordinate. So you can do infinite. Or the infinite side, which I'm not good at drawing. Now the range is a little bit wonky because you have to figure out the exact y-coordinate that the vertex lands on. So since it lands in the negative, we know our vertex. So if we're counting by ones, this is 1 and this is 2. So our vertex is 0, 2. So our range would be y is greater than or equal to -2. And because since it's going upwards, that means it'll hit all of the things going past -2. Now for example 2, we can also figure out whether or not this graph is a function by the vertical line test. So if we draw a line right here, it hits 1 and 2. So this is not a function. So since this is a circle, we have to find the exact domain and range. So if we count by ones, the domain would be 1, 2, 3, 4, 4, and then -4. So our domain would be -4, -3, -2, -1, 0, 1, 2, 3, and 4. Now for a range, we'd also have to find the y coordinates that it lands on. So if we count by ones, let's just imagine that this is 4 and that this is also 4. So we can also write this as the domain is -4, -3, -2, -1, 0, 1, 2, 3, and 4. And that's how you figure out whether or not a graph is a function or not.
The concept of mapping and key vocabulary is domain, range, and function. In our example, we have a set of coordinates. So we're going to have to find a domain. A domain is basically the x value, and range is basically the y value. So what we're going to do here is we're going to get all the x values and put them in order from least to greatest. And we're going to get all the y values and put them in order from least to greatest, as demonstrated here. Now, concept of mapping is the exact same thing. And we're going to have domain and range, while also having to connect two back to the left. So we have 0 going to 3, we have -2 going to 1, -2 going to 3, demonstrated here, 5 going to 4, which is 5. Now, the reason this isn't a function is because domain 2 goes to 2 y values or range, it goes to -1 and 3. And that's why it can be a function. But on the following example, we have another set of coordinates, and we're going to do the exact same thing. We're going to separate them by the domain and range. So we're going to have -1, 0, 2, and 3, -1, 3, and 5. You can see the x values, and we'll see y values for range. For mapping, same thing. Domain range, we have -1 going to 5. We have 0 going to 3, 2 going to 3, and 3 going to -1, shown here. Now the reason this is a function, even though we have two things going to one range value, is because that's allowed. We can, if we had 2 going to 3 and -1, then it wouldn't be a function. But since we have two different x values equaling another y value, it's a function.
Hi everyone. So you might be wondering, how am I ever going to use this in the real world? Well, here's the situation where you might need to use it. The problem is, Andrew is filling his empty truck with gas. He chooses to use diesel type gas, which is $10 per gas. How much money will he pay depending on the amount of gas he chooses to put in?
So question A asks if this is a function, and we can figure this out by determining how this would be a function. So since we could say that the amount of money is dependent on how many gallons of gas he puts in, then money would be the dependent variable, which is y, and then the amount of gas would be x, because that's what you purposely changed. So since those would be proportional to one another, you can say that yes, this is a function. Now question B asks to write an equation that goes with the problem and to graph it. So since we know that it's $10 per gallon of gas, and that it's empty, meaning 0 gallons, we can assume that for an equation that says y equals mx plus b, since that's the y-intercept, would be 0. So right now we have y equals mx plus 0. And since 10 is our slope because it's going up by 10 per each gallon of gas, we know that m would be 10. So y equals 10x plus 0. Or y equals 10x if you don't want to write down the 0. Now to graph it, we'll say that this is our origin. And we can go up by 10 per mark. So we have 10, 20, 30, 40, 50. 1, 2, 3, 4, 5. So 1 gallon of gas would be $10, 2 would be 20, 3 would be 30, 4 would be 50, or 4 would be 40, I bet. So, just draw that line, and there you have it.